I took a walk outside today, did some visual measuring, just so I could kind of show you what it means to do visual measurement in kind of a complex space. So what I'm doing here is measuring the foreshortening of the driveway. And the way I'm doing that is measuring the length of the driveway. There's my thumb right there holding the pencil. And I have the pencil tip at the end of the driveway. And I'm going to relate that to its width. And that will give me the degree of foreshortening that's taking place in terms of this long passage, right? So I take that and I turn it sideways. Now I keep the pencil same distance away from my face as I'm turning it sideways, and I just stack it across. Got 2.5. A little tricky to stack things. Take some practice. Do it again. There's 1. Keeping that straight up and down, parallel to my face. I don't push it in the direction of the driveway. Never do that. Always keep that parallel to your face. And then there's 1, 2, and about 1/2. So if I was drawing that driveway, I better make darn sure that its length, right, the vertical height on the drawing, right, from bottom to top of that driveway, fits across the width 2.5 times. Now I'm approximating the angles of the lines that are running away from me, right, that are moving towards the vanishing point. And, that's probably a 45-degree angle there, I would think. Relative to the picture plane, right, the flatness of the picture plane. So if I'm drawing that edge of that highway or that driveway, it would be a 45-degree angle. On both sides, probably going the opposite way. There's a little angle to the bottom of the windows there too, as well, right? Approximating that angle. Now we know in reality it's horizontal, but it's pitching down a little bit because it's above my eye level. So all those lines, this line, these lines would meet over here at what's called the vanishing point, right? It's a pretty traditional one-point scheme here. How do we know that? These horizontal lines here are facing us, they're just going straight across on the page. So it's kind of, they're facing us directly. So that kind of makes this a one-point scheme. Got something else here. So the garage, first thing to think about is like, how big is that? What's the proportion of that garage door, for instance? We know it's wider than it is high, but by how much? So what you do is you grab the shorter measurement first. In this case, it would be the height of that thing. So I'm sliding my thumb down till it's at the bottom and putting the pencil tip at the top. Now I have to close one eye to do this. You can't do it with 2 eyes. The camera does it automatically because it only has 1 eye, right? So there's the tip of the pencil, there's my thumb. So I've grabbed that measurement. Now we know, in fact, that it's a lot bigger than that, right? The garage door is way bigger than that length on that pencil. But from my point of view, where the pencil is relative to my face, that's a good way to measure it, right? And then I'm just going to turn that sideways and walk it across the length of it. So if I was drawing this garage, I would have a proportional relationship. It'd be like 1. Sometimes I put my finger there as a way to. So almost 2. So I can make the drawing of the garage any size I wanted to, as long as the height of the door opening fits across the width approximately 2 times, it's going to be in proportion. Okay? There's no foreshortening going on here. It's just a length to width of an object, in this case the garage door. Now I'm measuring the whole height of the garage and maybe kind of relate that to its width. I get a 1 and a little bit left over. So there's the amount that's left over, maybe 1/4, right, of the whole length of that pencil. So there'd be 1 and 1 1/4. So I would apply that to my drawing. So I can make the drawing any size, tiny little drawing, as long as I'm maintaining these proportions. And you're always measuring one versus something else. In this case, the A-frame. 1, there's the 1, the height of that A-frame. Walked across the length of the door goes 2 times. Now I'm measuring the length, the height of the A-frame versus the height of the door. Another. You got thousands of relationships you could make in a drawing. And the more relationships you make, the better the drawing will be. You know, the more accurate you'll be. They're measurements, right? You're just measuring the world. So this building's way far away, right? This little shed. But I could make a visual relationships of that versus something up here, maybe the height of the doorway. So that shed fits in the height of the doorway 1, 2, well, about 3 times, a little less than 3 times, maybe 2.5 times maybe. Now, if I brought that over here and put it in front of the door, we know it'd be much bigger. But it's so far away, but I'm drawing it far away, right? So I got to kind of figure out what that, how big to make that little shed relative to the door. So that's a this to that relationship between 2 objects in space. It's not just a proportional. And now I just measured it, you know, the height of the little shed versus its width. Now I'm doing a negative space, a thing that does space. There's no object there. It's just a space between 2 things, and I relate it to something in the drawing. So the space between the garages fits exactly in the height of the garage door. That's fortuitous, right? So if I was drawing this, it'd be an easy relationship, right? I just make sure in my drawing that when I'm drawing this thing, the space between those 2 garages fit exactly into the height of the door and vice versa. And you could, like I said, there's thousands of relationships you can make, cross references in terms of visual measurement in a drawing. So now I'm going to kind of focus on the these squares in the cement driveway here. It's a 1-point scheme. We know that because generally this line is horizontal to the bottom of the paper, right? These lines here are horizontal to the top and bottom of the paper. So these lines go to one vanishing point somewhere. Now, this block actually in real life is the same size as this one, but from my measurements, it's about 2.5 times smaller, right? This one fits into this 1, 2, and about a half again, right? So when I make the drawing of that, I would make darn sure that this thing is 3.5 times, the vertical height of this is 2.5 times bigger than that, right? Now I measured the height of this, and I got 2.5. There's the 1, right? Right there. Pencil tip, thumb. Now I'm going to turn that sideways and walk it across here. It feels like it's longer in this dimension than it is in this one, right? But we're finding it's almost 2 times as wide this way as it is this way. That's how depth will kind of mess with your brain a little bit. So there's the 1. Turn it sideways. So I'm measuring a length to width of something and estimating the foreshortening quality. Yeah, it fits across 2.5 times, right? So this space here fits across here 2.5 times. Doesn't feel that way, but I just measured it, right? And there's some angle approximation again. And those would go past the building here to a vanishing. Where they converge would be the vanishing point in a 1-point scheme. Now I move over a little bit, right? These angles change. That gets more severe. This one goes almost straight up and down, not quite. So you change your place in space, the space changes. Your relationship to it changes. Now everything I'm doing with the pencil here is I'm keeping it flat to my body. I'm not pushing it away from me. The tendency is, because that driveway moves away from us, right? Flattens out. That pencil, believe it or not, it's just still flat to my body. It's just at an angle. So never push the pencil in the direction, because you're violating the flatness of the picture plane, which is you're trying to kind of ascertain here. So I'm just kind of messing around with the lengths of these passages and kind of relating. So that this, oddly enough, this length right here fits into here an extra time. This seems shorter, doesn't it? But this is actually longer by 1.5 times. Weird. So your brain's going to constantly play tricks on you. So here I'm measuring the height of these pants hanging on the line to the door, right? And I get 1 and maybe a third extra, right? The wind stopped blowing. So these pants almost fit in the height of this door one time. Now we know they're way smaller than that, just as that they're closer to us than the door is, right? So that's establishing a this to that relationship with two separate objects in the space. Now I'm going to measure the space down the clothesline there to the garage, that negative space, and relate it to the door again. I get that fitting in the door just about twice. So this space right here fits in the door twice. Now you'd have to figure all this stuff out if you're to draw this scene, right? Because your brain's going to, you just can't kind of go with the first thing you think is right. That's what, separates a professional from a novice, I guess, from somebody who's drawing in a naive way. So there's the truck. Now, first thing I'm going to figure out is how high, what's the relationship of height to width or length in this case of the whole thing. So there's my 1. So 1 vertical. I turned it sideways. 1, 2, 3. So believe it or not, this distance right here fits down the whole length of the truck 3 times. And I'm double and triple check it, right? If I were to draw this. You guys are new at this, so you got to kind of practice it. Play around with these cement blocks here a little bit more too. So the height, the front to back of that square fits across the front edge 4 times. Even though if I were to take a tape measure and go over there and measure them, they'd be the same, right? See, I'm sliding my thumb up, right? So I'm grabbing that measurement, closing one eye, keeping the pencil same distance from my face, and then just totem poling it over, right? Stacking it across. So if I draw that shape, I better make sure the vertical or the depth of it is 1, 2, 4 across the front, right? I think that's what it was. And again, just, kind of practicing the angle approximation there. So, there's thousands of things out here I could measure, right, relative to each other. So I'm measuring 2 separate things, right, that you wouldn't think about measuring. The height of that cement passage to the height of the bed of the truck, right? Kind of about the same, right? So that would be a good reference. Now I'm measuring the height of the bed of the truck to the length of the bed of the truck. It's a 2-to-1 relationship. What's the front, maybe, of the whole truck versus the back? 2-to-1. When I look at the truck, though, it looks like the front's a lot bigger than the back, right? But there's my 1. Slide it over. That fits perfectly in the whole length of the truck, right? To this tailpipe right over here. You got to take in consideration this, of course, but it fits about 3 times. So the height here fits down the length about 3 times. Now I'm just kind of playing around with that to maybe the height of these doors over here, right? So you get 1 and a little extra. So the height of this, if I was drawing this scene, I better know what the relationship of this is to those doors. Again, now this would be an example of where it's a 2-point scheme, because these lines right here, see I'm lining the pencil up along that, that's not parallel to the bottom of the drawing, is it? Or the bottom of the video screen here in this case. So that would be a 2-point perspective scheme. It gets more complicated that way. This, we're back to 1-point perspective scheme because we're facing that edge of that, or the plane of that part of the house there straight on, right? So, first thing I'd probably want to figure out is what's the height and width of that window segment there, right? So I get 1 to 1.5. See where that window kind of peeks out behind the pencil. There's the 1 to 1 and about 1/2 right there. Now I'm going to measure that versus the height of the whole structure there. So I get 1 and a little under 2. So the width of this stacked vertically gives me a 1 to 2 relationship. What's this negative space here? How do I measure that? So I'm measuring the negative space and stacking on the whole height of this thing to figure out how far over the windows are. There's the 1. Now I go 1, 2, 3, about 4. So this little space here fits in the whole height about 4 times. Now I'm trying to figure out what this awning, its relationship to something. So that awning fits in the height of the wall 2.5 times. See how you can cross-reference everything in a drawing? And here I am double checking it, right? Just to make sure. So if I was drawing this scene, I'd go back to my drawing and make sure that the drawing conforms to that, right? And again, I can make the drawing any size as long as those proportions fit. Now there's the angle approximation of this driveway, the edge of the driveway. It's a lot more flat, right? It's a lot more horizontal because I'm moved way over to the left. So that thing really flattens out. I measured the whole passage here and stacked it in the height of this. Now I'm measuring the negative space between the pole and the house versus the height of that part of the house. I'm getting this space from here to here. Look, you got to look for spaces to measure. So if I was drawing this drawing and I didn't know where this pole was, I'd know now where it is. I know that I could split this in half. Half of this turned sideways would be where that pole is. Do it again here. I think I do it again. So there's the 1. There's the negative space between the pole and the house. And I'm going to see how many times that fits in the height of the house. So let's say I finished the height of the house, but I don't know where that pole is going to go in my drawing. Now I know. There's 1. And we'll pop up on that 2. So that fits twice in there, right? Now I'm moving over. This space has gotten bigger all of a sudden. This has not. So what's the relationship now? That fits in the height of that no longer 2 times, but 1 and maybe 1/3. See that? The rest of the pencil's off the edge of the paper there, off the edge of the screen. So that has radically shifted. I'm seeing way more of the driveway in the opening down there. 1 and 1/3. Used to be 2. Move over a little bit more. What is it now? So this hasn't changed. The height of the house hasn't changed, but this opening has changed because I've moved in space. I've moved laterally. So I'm going to grab that new measurement, slide my thumb back down. See, I had to slide. I'd increase the length of this. Here's my thumb, closing one eye, and I go to the house. Now, what is that in relation to this? Take a hazard to guess here and be maybe 1 to 1. I don't know. I think that's what it was. We'll find out. There's 1, turn vertically, 1. So from this point of view, if I'm drawing this scene, looking down the driveway, the space between the telephone pole and the corner of the house would be equal to the height of the house, right? That's visual measurement. And again, I'm keeping the pencil the same distance from my face, or in this case, the camera lens, right? I'm not moving it in and out when I shift to the other measurement. So when I move from that measurement to that measurement, it's staying the same distance away from my face. Otherwise, it changes its relationship to the space. You always have to keep it the same and parallel to your body, right? Never tip it in the direction that you're looking. So I think that's it. Okay, just a quick little tour of the side yard there and house, and kind of did some visual measurement. It's a very difficult thing to do. It's kind of one of the most difficult things that I find for students to understand. So all you're looking for is a proportional relationship of this to that. It could be in the same object, could be 2 separate objects, could be testing the foreshortening, how far something's moving away relative to how wide it is, etc., etc. but visual measurement's a very, very important component to observation-based drawing. Okay, thank you.